Hello students, I am Dr. Saleha Jamal, Faculty Department of Geography from Aligarh Muslim University, Aligarh. So today's topic of discussion is climate change and its impact on cryosphere, which is in continuation to the previous lecture that we were talking about the evidences of the climate change that supports the first perspective that the climate change is real. So let us start today's class. Students, welcome to the class. So what is cryosphere? Let us discuss. You must have heard about the ice sheet, ice cap, glaciers, permafrost, snow cover, etc. Actually, the cryosphere refers to all the frozen water parts of the Earth system, whether it is glacier, ice cap, sea ice, permafrost or snow cover. Means all the frozen water part of the Earth system can be called as cryosphere, and it has amount of importance. Few of it you can enumerate as this cryosphere regulates the global climate by reflecting the solar radiation. Means solar radiation which is received by the Earth's surface, this cryospheric layer that they use to reflect this solar radiation. These cryosphere, they stores a significant portion of Earth's fresh water, which also supports various human livelihoods. Even this cryosphere supports several ecosystems, particularly in the polar and the mountainous region. If you find out some of the major regions of the cryosphere, you can see either in the Arctic, Antarctic, Greenland, Himalayan region and even other high altitude, or we can say high altitude regions of the different mountains. So now it must be clear that students, that any sort of, we can say, frozen water part of the Earth system, that can be called as cryosphere. And here we are discussing the impact of climate change on cryosphere. Some of the key observation of what the cryospheric changes are taking place due to the climate change. So among this you can enumerate glacier retreat have been observed, sea ice is declining, permafrost is thawing and snow cover is melting. When we talk about the glacier retreat, glaciers overall the world are shrinking due to the global warming, that is rise in global temperature. Here we will take certain example in this lecture further in our different slides. For example, the Himalayan glacier have lost a significant ice mass over the past decades. When we talk about the sea ice decline, the Arctic Sea, or we can say Antarctic sea ice, they are reducing in extent and thickness even with the record low levels in the recent years. Similarly, the permafrost thawing is taking place due to the global warming, and this permafrost thawing overall creates a positive feedback loop. Means due to the thawing of the permafrost, greenhouse gas is released in the atmosphere, like methane is released in the atmosphere, which again increases the global temperature. Talking about the snow cover, reduced snow cover, even the snow cover durations have been reduced, the extent of the snow cover have been reduced, particularly in the mid-latitude due to the global warming. Let us take various examples. Here just analyze here, I am talking about the Arctic ice sheet mainly in 1990s. I am talking September 1991 and March 1992. You can analyze the two-season Arctic ice sheet of 1990s. This is the line which is demarcating the extent, the yellow line. Just observe here. This is the yellow line and again this is the yellow line which is demarcating the extent. Students, just see this yellow line where the cursor is moving. Again you can see here where the cursor is moving. Now just see the change in 20s. Just observe it. How much reduction have taken place? In this ice sheet have been reduced a lot in these 3 decades. This is from 1990s, this is from 20s, 2020s. Once again you see 1990s, 2020s, 1990s, 2010. So much reduction in the ice sheet has taken place. You can clearly see the impact of global rise in temperature on the ice sheet, particularly of Arctic. Let us take another example from the Antarctica ice sheet. This is again, we can say, the pictures that is of September 1990 and February 1991, two seasons that have been taken. Again, you can see the yellow line demarcating the extent observed from, mainly received from Earth Observatory NASA. See the extent that is reducing. You can clearly see here. You can clearly see. Even you can clearly see this portion. You can clearly see even this portion. So lots of reduction have taken place, particularly this. You can see how much reduction is taken place. Similarly, here also you can overall see this portion. Sorry, you can see. So I am talking about this portion. All you must observe that this portion there is an increase in the ice cover, but see to this portion and this portion. I am talking about this and this. There is decrease. You can see I am talking about this portion. There is, you can see. So this is another example from the Antarctica ice sheet in 2020s. So ice shelf carving. Actually, the satellite imagery here, this is the Halley 6 research station. Here you can see here, this is the Halley 6 research station, which is safe further inland on the Brunt ice shelf. This is the Brunt ice shelf we are talking about, students. Let us elaborate it. Actually, satellite imagery here confirms an enormous iceberg around 5 times the size of Malta, which has finally carved from the Antarctica's Brunt ice sheet. Means this is the portion which has been carved out from the Antarctica's Brunt ice shelf. This is, if we see, according to the British Antarctic Survey, which explains the break occurred in late January 2023. Means this breakage of this iceberg, huge mass of ice, that occurred in late January 2023. When I am talking about that, this Antarctica's Brunt ice shelf that got separated from this area, you must be thinking, what is Antarctica Brunt ice shelf? Actually, this Brunt ice shelf borders Antarctica coast, that is the land between the Dawson-Lambton Glacier and Stancomb-Wills Glacier tongue. Means it borders the Antarctic coast. So Brunt ice shelf actually borders the Antarctic coast. So this got separated in late January 2023, and new iceberg estimated to be around 1550 square kilometer and of having the thickness of 150 meter, that was carved out when the crack known as Chasm 1 fully extended northward, severing west part of the ice shelf. Means this is, we can say, Chasm 1. This is known as Chasm 1. This crack is known as Chasm 1 and it got extended, thus separating these two shelves. So this here you can see here the picture of 25 October 2022. This is whole of the Brunt ice shelf which got separated through this crack known as chasm 1. This is the image from the Copernicus Sentinel-2. Clearly you can observe that ice carving has taken place. Overall, we can say that shelf carving has taken place. In previous pictures, you have seen how the ice cover, overall ice sheet of Arctic and Antarctica is decreasing, and here we are seeing the ice shelf carving of Brunt ice shelf. Another example here you can see the Matterhorn mountain which is located in the Alps. This one is the photo of 1960 taken by the Bradford Washburn, and this photo is taken in 2005 by David Arnold. Clearly you can see the difference here, student. Clearly this is the whole, this mountain is covered with the ice. Now see the cover of ice, it has reduced a lot. So see the changes. The main reason behind this is global rise in temperature due to global warming. Another example here you can see Mount Kilimanjaro in Tanzania. Images mainly taken by NASA Landsat satellite. Credit to Jim Williams, NASA GSFC Scientific Visualization Studio. You can see here the picture of February 17, 1993 and again February 21, 2000. Now see the Mount Kilimanjaro of Tanzania, the ice cover. It has reduced a lot. Shrinking of this ice cover is clearly visible from these two photographs. Another example from the Peterson Glacier in Alaska. This is the photo of 1917. Full. See the extent of expanse of this glacier. You can see. And now in 2005, almost lost. Here you can clear impact of global rise in temperature is visible from these two photographs. Climate change effects on Canada's frozen land, which was very much in news from last few years. Glaciers, particularly in the Western Canada, are experiencing extreme rate of recession in the recent years. Even for the first time in 2023, glacier mass balances got decreased during the winter. This was the first time even in the winter the decrease in the mass balance have been observed during the winters. Summer ablation is also very much high. Taking the example of Pito Glacier in Banff National Park, we will see just now the Pito Glacier that retreated astonishingly 409 meters. See the how much it is retreated and decreased 29 meter in height just between 2009 and 2003. See the time period and see the decrease 409 meter it has retreated. Even it has decreased in thickness, that is around about 29 meters. Various other glaciers in the Columbia ice field and other mountain regions are in the same position. Retreat is continuing. Even the thickness of the glaciers is also decreasing. According to the rate of this retreat, it has been projected that the glaciers across Western Canada will lose between 74% to 96% of their volume by the end of this century. That is a fate unlikely to change even if we meet the 1.5 degree centigrade limit, which is particularly set by the Conference of Parties of Paris Agreement of 2015. If we are able to maintain this increase of just 1.5 degrees centigrade, then also it is projected that the Western Canada will lose so much of their cryospheric volume. So just take the example of retreat of Pito Glacier. You can see here 2019 and 2023. Pito Glaciers of USA. See the retreat 2019 picture. See the extent, and you can see the retreat just in 2019, 20, 21, 22, and you can say this is the 23. See the retreat, and all the lateral retreat average is given in 2022 80 meter, 21 120, then 195 and 12.5 meter. See, you can see the retreat amount. Overall 409 meter retreat have been recorded, and 29 meter ablation means thickness have been recorded between 2019 and 2013, means clear retreat, or we can say clear extent, decrease in the extent have been observed. Let us take another example of Greenland ice sheet. Here the melting days are increasing by the passing time. You can see this is the melting days from 1979 to 2007. You can see here the melting days. How many melting days? Now you can see the extent, the melting days in red, orange and these color, the melting days. Now see another map of 2012, mainly this is from National Snow and Ice Data Center. In 2012, you clearly at a glance you may analyze a lot of days have been increased, the melting days have been increased. Why these things are happening? Even the melting days are increasing, the extent of ice cover is decreasing, the thickness of the ice cover is decreasing. That is mainly due to the global rise in temperature, which is due to the global warming, which is again due to the increase in the greenhouse gases in the atmosphere. Another example from India, you can take the glaciers of the Himalayas. The Himalayan mountain range has the world's largest concentration of glaciers. If you see outside of polar ice caps, you can see here, find few of the circles, very few of the circles in orange color, which shows advancing glaciers, we can say. The glacier condition is advancing. Very few are in red in color. I can find only one. Here is circle red in color, which depicts stable glacier, no advancement, no retreating, we can say. But you can find most of the circles are black in color. Bunch of circles you can find black in color. It depicts the retreating glaciers. Means you can see here high rate of retreat of these glaciers. You can see the retreat 3 meter per year, a lot. Again you can see here 22 meter per year, 11 meter per year, 6.5 meter per year, 30 meter per year, 17 meter per year, 42 meter per year. Just see how much it is retreating. The black circle is especially signifying the retreating glaciers. Means overall retreat in glaciers have been observed even on the Himalayan glaciers. See here the retreat from 1780 to 2001. See the retreat of glacier from 1780 to 2001. At a glance you can analyze that the glaciers have retreated a lot. This is the pictorial representation of shrinking glaciers in Kilimanjaro. You can see here clearly. These are the photographs. 1928. You can see 2006. You can see so much retreat of glaciers. So much retreat of glaciers have taken place. This is 1998 and 2000 and again 1912 and 2006. So much retreat of glaciers have taken place. Here you can see the dark green color that shows the approximate glacier extent in 1912, the dark green color, and the light green color that showed the glacial extent in 2003. Again, you can see the decrease in the glacier just at a glance. One of here you can see again very important example which clearly points out towards the impact of the global rise in temperature, that is permafrost reef. Here mainly the regions which are colored in red, where the annual air temperature is averaged less than or equal to 0 degrees centigrade for the period of 1901 to 1910, but not anymore for the further period of 2001 to 2010. Even now also we can say areas in white remain permafrost during this study period, but this period the temperature rose above 0 degrees centigrade. So, the further permafrost cannot be maintained and it started thawing. So, this is another example which supports the evidence of climate change through the cryospheric changes. Few of the consequences of the changing cryosphere. Obviously, when the cryosphere will melt, it will thaw, the water will go somewhere. So, it impacts sea level rise, the melting glaciers, ice cap that will continue to global sea level rise. There will be the reduced freshwater resources. So, and it will impact mainly the communities which are dependent on the glacier fed rivers. They will face water scarcity, and even on the communities just living below these mountains which have have the major source of fresh water supply from the glaciers, they will be impacted. The changing cryosphere has a direct impact on the ecosystem. Various habitat is lost, and mainly the species living in these ecosystem, just like polar bears, snow leopard, will face various challenges. Among the consequences, there is one of the major consequences is on albedo effect. We know global warming and climate change is continuing, due to which melting of ice and glaciers are reducing. Melting of ice is taking place, melting of glaciers is taking place. Overall, cryosphere is being reduced. This decrease in ice color will decrease the albedo of the earth, means reflection, because cryosphere maintains the earth's albedo through the reflection of the received solar radiation. So, reflection will reduce, absorption will increase. So, thus the decrease in the albedo of the earth is being observed. Thus, the earth will receive more energy from the sun and there will be rise in the temperature. So, overall, as the surface area of the high albedo glaciers and sea ice shrinks and reduces, more solar radiation is being absorbed by the earth, which accelerates the cycle of warming and melting in destructive feedback loop. So, students, that's all for today's lecture. Have a nice day. Thank you.